Hi everybody, I am still at home, really wishing that I was able to come to school, and I can't. My son is sick, and I'm going to have to stay home with him on Thursday. So I thought it might be helpful for you to hear me go over this task. If you feel pretty comfortable with it, that's fine, and you can bypass this video. But the test is still definitely going to be on Friday. So, the key to this problem is that the x-axis is on the water line. It mentions that there, so this is the water. And the radius is 100 feet. So I'm not going to write all of my answers out. I'm going to kind of abbreviate just because it's hard to write in this small space. But it's asking for the first question, what do the x and y values represent? The y values is essentially the height or how far it is from the water level, because it could be negative, it could be under the water. The x is kind of just like how far horizontally, like the horizontal distance. Sorry, this is hard to write with. So it's the horizontal distance from the center of the water wheel. I kind of mentioned positive and negative values already. Negative y values is under the water. Positive y values are above the water. And negative x values are to the left of the center of the wheel. Positive x values are to the right. So that makes sense. The highest point is going to be 100 feet because the radius is 100. So way up here at point D, that's going to be at 100. And the lowest is going to be down at the bottom, which will be negative 100 feet below the water. The heights farthest to the left or right of the wheel are going to be 0, just because it's not going to be going up or down, and the farthest to the left and right are going to be these points that are on the actual, like on the circle on the water. If A rotates to B, how many radians and degrees has the wheel rotated? So there's a couple of different ways to think about this. I'm thinking there are 10 sections in the whole entire circle, which means there's 5 sections in half of the circle. So if half of the circle is pi, and I have divided it into 5 sections, that means that the angle right here between A and B is pi over 5 radians. To change that to degrees, I could also do 180 divided by 5 and see what that is. Or I could do the converting this, multiply by 180 over pi. Notice it's the same thing. It's 180 divided by 5. And that is 36 degrees. If A rotates to point D, that is going to be here. And that is a quarter of the circle, which that's just pi over 2 radians or 90 degrees. Either one. And if we label the ordered pairs, I'm going to do it as we go. So I'm starting at A. This is going to be 100, 0. It's parentheses. Up here we have 0, 100 at D. G is going to be negative 100, 0. And J is going to be 0, negative 100. So that answers question number 8. Question number 9 is an important one to me, and I added this on here because I wanted you to be better prepared for your test. So you can definitely expect to see something like this. So a bug starts at point A and rides to point F. So notice I'm highlighting here the path of the bug. So it's a part of the circumference, right? There's a couple different ways you could do this. You could figure out what fraction of the circumference that is. So since there are 10 sections in the circle, that is 1, 2, 3, 4, 4 sections out of 10, 4 tenths. So I could do 4/10 times 2 pi r, which r in this case is 100. And that would be acceptable. So let's see. Doing some math here. If I do 100 divided by 10, that gives me 10. So I'm going to go ahead and divide those and get 10. And then 4 times 2 times 10 is going to be 80. So I got 80 pi. And that'll be feet. 80 pi feet. I could actually multiply the pi out and get a decimal if I wanted to. Another way to figure out how far it traveled would be just to think about what a radian is. So remember, a radian is the distance or the arc length divided by the radius. So if I want to find the distance, I know that the radian in this case is 4 pi over 5. I don't know what the distance is, and I know that this is 100. So if I solve for d, I would multiply by 100 on both sides. And that is also going to give me 80 pi. So either way is going to work. One thing that was actually not on here, but I kind of wanted to ask, was what if I had asked, like, how far did the bug fall? So if we look back up here at the drawing, I'm going to draw like in green, the bug got to point F and then it fell down right here. So if we were trying to figure out how far it fell, the radius is 100. There's several different ways you could do this. I think I would kind of think about it like triangles. This is not something that's on the unit circle, so if I asked you this question, you would have to have a calculator for it. But if it was on the unit circle, you don't have to have a calculator for it. So I know that that's 100. I'm looking for this y value. Okay, I'm looking for y to see how far it fell. And I know that this angle right here is pi over 5. Like, that's the reference angle if I'm just looking at the triangle. So I'm going to actually draw the triangle on another page here. Okay, so if we're at point F, I know that this reference angle is pi over 5. I know that this is 100 feet, and I don't know what the height is. I'm going to call that y. That's what I'm looking for. So here's where I can use trig. The y is the opposite side, and the 100 feet is the hypotenuse. That means I'm going to need to use sine. Sine of pi over 5 equals opposite over hypotenuse. Trying to solve for the height, so I'm going to multiply by 100 on both sides. And again, if this was on the unit circle, I would know what this was. You know, if it was sine of pi over 4, I would be like, oh, that's square root of 2 over 2. Except it's not. So I would have to actually type this in my calculator and get an approximation. And you would have to be in radian mode. So I kind of just wanted to mention that as a side note in case you were asked a question about height or even about like horizontal distance as well. All right, these are the answers to the other practice sheet. So feel free to pause the video and just double check your answers. Had I been in class, I just would have asked which questions you would like me to go over, so I'm sorry that I cannot do that, and I will do my best to be there extra early in the morning on Friday so you can come ask me questions. But I can work out at least a couple of these just to make sure you're good with the concept. If we were to do this one, let's do that one. Sine of 5 pi over 6, negative 5 pi over 6. So positive 5 pi over 6 is just before pi. It's right there. So if I'm wanting to do negative 5 pi over 6, it's going to be over here. And that point on the unit circle is negative square root of 3 over 2, negative 1/2. So that's what I'm going to use to answer all my questions. Actually, it only asks for sine. So sine is just that. That's all it takes. Number 9, if I wanted to do the secant of negative pi over 2. That is here. That point is 0, negative 1. Secant is the same thing as 1 over cosine. So if I apply that to this, that's going to be 1 over 0, which is undefined. No way, Jose. Let's do one more. I'm thinking this one, evaluating all 6 trig functions for that angle right there. First, we need to think about where that is. So in my head, I'm kind of thinking, okay, one time around the circle is going to be 12 pi over 6, since that is 2 pi. So it's going to go all the way around the circle once. That's 12 pi. And then what's left is 7 pi over 6. And that is going to be just past 1 pi. 6 pi over 6 would be 1 pi. So we're talking about this angle right here. And on the unit circle, on the unit circle, that is negative square root of 3 over 2, comma negative half. So if I'm evaluating all 6 trig functions, sine of t is going to be negative 1/2. Cosine of t is going to be negative square root of 3 over 2, and I can see that just from the points. Tangent of t is going to be sine over cosine, so that's going to be negative 1/2 over negative square root of 3 over 2. If I reduce that, always leave the numerator the same. Reciprocate the denominator. Except I forgot to actually reciprocate it, so I'm going to erase that. So reciprocate the denominator. Those cancel. I get negative, well, they don't cancel, they divide to get 1. And actually, since both of those were negative, my answer is positive. And if I multiply it by square root of 3 over square root of 3, I get square root of 3. So I get square root of 3 over 3 for tangent. I'm going to go over this way just so I have space. Secant is just going to be negative. Nope. Oh man, I'm messing up all over the place. Secant goes with cosine, so that's going to be 2. Here we go. So that's going to be negative 2 over the square root of 3. Multiply that by square root of 3 over 3, and I get negative 2 square root of 3 over 3. So that's secant. Cosecant goes with sine, so that's just going to be negative 2, because I just flip the negative 1/2 up there. And then the last one is going to be cotangent of t. And I am looking at tangent right now, and I think I mentioned this in class, but this fraction, or I'm using a highlighter, this fraction, and this fraction are all equivalent, so I can really pick any of those to reciprocate. And I'm going to pick the one that's the easiest, which is this one. If I reciprocate that, I just get square root of 3. So there are all 6 answers: sine, cosine, tangent, cosecant, secant, and cotangent. There's all 6 of them. Again, if you find yourself having more questions, definitely feel free to email me or come by and see me in the morning. My email address is natalie.boyd@mmps.org. I apologize for how sloppy and a little thrown together this was, but hopefully you found it helpful since I was not able to be there in class on Thursday.